Dear partners and friends, welcome to the virtual visit of the Mosaic prototype. Unfortunately, you have not been able to join us in person today, so we have prepared this short video with some figures and sequences of the prototype's construction and operation. The Mosaic prototype has been constructed at CENER's Large Wind Turbine Test Laboratory in Sangüesa, 30 minutes away from CENER's headquarters, where enough space and logistics for such a large demonstrator were available. For the design, erection, and commissioning of this prototype, besides all required subcontractors for labors and civil works, more than 60 people from the consortium partners have spent long days and nights during the last 5 years. Let's start with some pictures of the system construction. The first step in construction of the prototype was the positioning of the circular foundations needed for the solar field structures. Then, the 4 metallic towers for the tracking system were erected, as well as the 5th tower that holds the heat transfer fluid circuit. The heat transfer fluid skid, containing all the required components such as pumps, tanks, valves, cooling system, and control, was assembled in the workshop and then raised to the top of the tower. Once the towers and skid were ready, it was the turn for the flying receiver. Initially, a dummy with similar geometry and characteristics was attached to the tracking cables and raised for system verification. Once the system was fully checked, it was substituted by the real and much more expensive one. The final part of the construction was the solar field. For this, the 3x3 mirror modules were pre-assembled in the workshop and then placed on the solar field supporting masts, while the 5x5 mirror groups were directly installed on field. The most critical and demanding part of the solar field construction was the mirror canting. At nights, a laser placed in the optical center of the spheres was used to adjust the orientation of the mirrors, ensuring a precise solar field shape for reaching high concentration. After all this work, recently, in October 2021, the Mosaic prototype was ready for the initial tests and for definitively validating the Mosaic concept and assessing the performance of the system. For you to have a clearer picture of how this prototype looks like in real life, let's go through some of its main facts and characteristics. The most important and impressive element of the prototype is the fixed solar field. The main shape of the solar field is a semi-Fresnel sphere made of 3 zones, a central skullcap, and 2 concentric rings. These 3 zones correspond to 3 spheres with different radii, 15, 16, and 17 meters respectively, sharing the same geometric center. The complete solar field is composed of 451 mirror facets, each one slightly curved to the shape of a sphere and with a size of 1 by 1 meter. This results in a solar field of 451 square meters of high-quality solar mirrors concentrating the solar energy. The maximum height of the uppermost mirror facet is 10 meters. As you can see, the solar field is surrounded by 4 identical metallic towers used to hold and guide the cables of the tracking system, as well as a 5th tower for the thermal loop skid. These towers are 20 meters high and are placed next to the solar field, making a total volume of the Mosaic prototype of 34 by 18 by 20 meters, comparable to a 5-level apartment building with 24 dwellings, not small for a demonstration prototype whatsoever. The cables of the tracking system hold the cylindrically shaped receiver. This 4.05 meters long receiver is made of 3 black painted 1-inch steel tubes in a spiral configuration and has an outer diameter of 30 centimeters. The overall length of tube for each of these circuits reaches 47 meters. The total weight of the main body of the receiver is approximately 565 kilograms. To be accurately moved by the tracking system, the receiver has special crossbars at its ends for the attachment of the cables and the lights. These additional elements, insulation, and others increase the total weight to be handled up to 1 ton approximately. The prototype also includes an oven to protect and warm the receiver, thus ensuring it's ready for operation at any time. It is an electrically heated oven located halfway up the skid tower. Finally, let's see very briefly how the system works. As already explained, thanks to the geometric properties of the sphere when it comes to light concentration, the Mosaic solar field concentrates the sunlight into a line from the sun and passes through the geometric center of the spheres. The maximum concentration is reached at approximately halfway between the mirrors and the sphere's center, which is precisely where we need to place the top of the receiver so we can catch the maximum solar energy at the maximum concentration. As the sun moves, so does the maximum concentration point, and the tracking system must move the receiver and correct its orientation accordingly to keep it at its maximum power. This precise movement and orientation of the receiver is possible by accurately actuating on the 8 cables of the tracking system attached to the crossbars that hold the receiver. An automated control system with a feedback loop based on artificial vision ensures that the receiver gathers the maximum amount of the concentrated solar energy at any time. All this configuration results in a 300 kilowatt thermal prototype able to operate up to 425 degrees Celsius with silicon oil as heat transfer fluid and all the components required for an automated operation. Since no power block is attached to the system, the generated thermal power is currently dissipated to the ambient, although it may be used as a heat source for different applications in coming research projects. Of course, this is a rather large but still first step of the Mosaic concept development. Next steps should be focused on paving the way of this innovative technology towards its commercialization. For this, it is mandatory to build on the experience of this prototype and the tests currently ongoing. As we have said before, this impressive milestone has been possible thanks to the hard work of the Mosaic team involved in all phases of the project, from the original idea and early pre-design work to the detailed engineering, construction, assembly, and finally operation of the system. Many thanks to the Mosaic team for making this possible, and many thanks to all of you for joining us on this very special day. You're welcome at CENER to visit the prototype in person at any time.